Hello everyone. In this video, I will be discussing the solutions of certain questions that have appeared in past year's JEE Mains papers from the chapter of lines in 3D and planes. Now, if you're not very thorough with the concepts of lines in 3D and planes, then I have left a link in the description box below, and this link is to lectures that I've made on lines in 3D and planes. Do have a look at those lectures and get thorough, get a firm grip on the concepts of lines in 3D and planes, and then get back to this video so that you can have maximum benefits of whatever I am discussing in this video. For all those who are clear with the concepts of lines and planes, let's get started. This question had appeared in 9th January 2019 JEE Mains papers in the morning session. Now this question says the equation of a line that passes through this point, which is -4, 3, 1. Second, it is parallel to the plane x plus 2y minus z minus 5 equal to 0. And third, it has to intersect this line. So the equation of that line which will be which of the given options. So what you can do is you can start eliminating the options from whatever conditions you already know. That will make our work a little easier. So I know that line, my required line, passes through -4, 3, 1. Check the first option. This line is passing through a fixed point, and that fixed point is -4, 3, 1. It might be my answer. It may be, it may not be. Check the second one. This line also passes through -4, 3, 1. Okay, even B might be my answer. Check the option C. -4, 3, 1. Okay, even C might be the answer. And option D. Okay, in option D, this line passes through 4, -3, -1. So option D is definitely my wrong answer. Unfortunately, I am not getting one answer straight away, but at least I am able to eliminate one of the wrong answers. So my answer might be either A or B or C. Check the second condition. The second condition says x plus 2y minus z minus 5 equal to 0 is a plane which is parallel to my required line. If my line is parallel to a plane, then normal to the plane will be perpendicular to my line. The normal to this plane is I cap plus 2j cap minus k cap. So I can say drs of the normal are 1, 2, -1, and that normal's dot product with a vector parallel to my line should be equal to 0, because like I said, the normal and the line are perpendicular. So 1, 2, -1, check with which of the given options the dot product will be 0. So for the first option, the parallel vector is -1, 1, 1. Its dot product has to be taken with 1, 2, -1. So I have 1 into -1, which is -1. Plus 2 into 1, which is plus 2, so -1 plus 2 makes it 1, and finally I have -1 into 1, which is equal to -1, and that 1 minus 1 will be equal to 0. So for the first option, the normal and the line are perpendicular. It might be the right answer. The second one, check with this. The drs are 3, -1 and 1, and the drs of the normal were 1, 2 and -1. So I have 3 into 1, which is 3. -1 into 2, which is -2, and 1 into -1, which is -1. 3 minus 2 -1 is equal to 0. So again, I am not able to eliminate all the options. From here, I realize that either A or B might be my answer. Check for option C as well. Again, the drs were 1, 2 and -1. So I have 1 into 1, which is 1, 2 into 1, which is 2, and 3 into -1, which is -3. 1 plus 2 minus 3 is equal to 0. Again, even that option C, the line given in option C, happens to be perpendicular to the normal. Unfortunately, with the help of the second condition, we are not able to eliminate any of the possibilities. Why am I not checking option D? I already know it is wrong, so why waste time behind option D? Now we will use the third condition. The third condition says that my line has to intersect this line. Now this is where the sum will immediately get solved. If two lines are intersecting, then the minimum distance between them should be equal to 0, and if the minimum distance between them is 0, then that numerator, the determinant which you had in the numerator, should be equal to 0. Check for which of the given lines that determinant value turns out to be equal to 0. So I start with my first line. The determinant value that I get for the first line is, okay, the determinant was x2 minus x1, y2 minus y1, z2 minus z1. So x2 minus x1 would be -4 minus -1, that is -3, 3 minus 3, which is equal to 0. Then I have 1 minus 2 equal to -1. A1, B1, C1 is -1, 1, 1, and this will be -3, 2, -1. sorry, minus 3, 2 and minus 1. So expand the determinant. You have minus 3 multiplied by minus 1 minus 2. Minus 1 minus 2 is minus 3 and that into minus 3 will be 9. Then I have a 0 and then finally I have minus 1 multiplied by minus 2 plus 3 which is 1 and into minus 1 will be minus 1. So this is 8. This is not equal to 0. It should have been 0 if the lines are intersecting. So I realize that this line and the line given in option A are not intersecting, which is why option A is also ruled out. It is the wrong option. Let's check for option B. For option B, try evaluating x2 minus x1. So we have x2 which is minus 4 minus 1 giving me minus 3, 3 minus 3 which is equal to 0 and 1 minus 2 which is equal to minus 1 and the DRs are 3 minus 1, 1 and this row will remain as it is because it will be minus 3, 2 minus 1. Evaluate this determinant. So we have minus 3 multiplied by 1 minus 2 which is equal to minus 1. So minus 3 into minus 1 making it 3. The second term will be 0 and the third term is minus 1 multiplied by 6 minus 3 which is equal to 3. So I have minus 1 into 3 which is minus 3 which is equal to 0. So option B might be the right answer. Now I have to check last for option C. If option C also the determinant value I get non-zero, then I am very clear that option B is the right answer. Okay, again in option C if you realize the numerator is going to be the same. Numerator in the sense the first row of the determinant. So I will be having minus 3, 0 and minus 1 and this row will be 1, 1, 3. Okay, so I have minus 3 multiplied by minus 1 minus 6 that is minus 7 into minus 3 is going to give me 21. The second term 0 and the final term is minus 1 multiplied by 2 plus 3 which is 5, so that's giving me minus 5 which is 16. Again not equal to 0. So I am clear that option C is the wrong answer. So that is why option B for this question becomes the right answer. Now it has taken me a little time to evaluate and discuss the entire sum. In JEE Mains, I know you don't have so much of time, but if you are able to think all of it by yourself, it's not really a long process. Many a times in JEE Mains it will so happen that you should eliminate the options and then go ahead with the question instead of completely solving it from the start. At times solving it from the start may be easier, at times eliminating the options like we did in this question would be easier. So you have to judge a question and then pick a trick to solve that problem. For the time being, I hope the method is clear to all of you. Like I said, option B is the right answer. Let's go ahead with the next question. Yet another straightforward question. The question says, on which of the following lines will the point of intersection of this line and this plane lie? So all you have to do is find the point of intersection of this line and this plane and put that point in the given options. Whichever option gets satisfied by the point is our final answer. So what we will do to find the point of intersection is, we will take the equation of the line, and we know that the coordinates of any point on a line are written in terms of lambda. So in this line, you can just equate the entire ratio with lambda and call it the parameter. That parameter, let us say that we are fixing the point on the line as the point of intersection. So when we fix the point on our line, the lambda value also gets fixed. So once the lambda value gets fixed, I can say that the value of x will be 2 lambda plus 4. The value of y is going to be 2 lambda plus 5. And the value of z will be lambda plus 3. Now these are the coordinates of your point of intersection, and since the point of intersection is going to lie on the plane also, these coordinates will satisfy the equation of the plane. So put these coordinates in the equation of the plane and that gives you 2 lambda plus 4 plus 2 lambda plus 5 plus lambda plus 3 equal to 2. Solve it, you will get your lambda value and put it back over here to get the point of intersection. So when we solve it, we have 2 plus lambda, which is 5 lambda, equal to, we will have 4 plus 5, that is 9, plus 3, which is 12, goes on the right, becomes minus 10. So I have lambda as minus 2, and I will put that lambda as minus 2 over here. So when I put it here, I get x coordinate 0, I get the y coordinate as 1, and I get the z coordinate as 1. So I just have to put 0, 1, 1 in the equations that are given to me, and whichever equation gets satisfied is our answer. So put 0 over here. 0 minus 2 upon 2 is minus 1. Put y equal to 1 over here. 1 minus 3 is minus 2 upon 2 is also minus 1. And when I put z equal to 1, I have 1 plus 3 which is 4 upon 3. So minus 1, 4 upon 3, they are not equal. So option A is not the right answer. Go ahead. X minus 4 upon 1. So 0 minus 4 upon 1 is minus 4. Then I put y equal to 1. I get minus 4 upon 1 which is also minus 4. And finally when I put z as 1, I get 1 minus 5, that is minus 4 upon minus 1 is 4. So minus 4, 4, they are not equal. Option B is also wrong. Go ahead. 0, 1, 1 in option C. I have 0 minus 1 upon 1, that is minus 1. Then I have 1 minus 3, that is minus 2 upon 2 which is also minus 1. And then I have 1 plus 4, that is 5 upon minus 5 which is also minus 1. So yeah, option C out here is the right answer. But always be double sure. There is always a possibility that you might have made an error in your calculations. Check for option D as well, and when you put it in option D, you will observe that the equation will not be satisfied. I am leaving this as an exercise for you guys. So over here option C will be the right answer, and let's go ahead with the next question. The next question, it says that let A be a point on this line and let B be any point in space. Now you need the value of mu, that mu will be obtained from the equation of the line. It's the parameter for your line. You have to get the value of mu for which the vector AB bar will be parallel to this given plane. So what we will do is, first of all, we need to find the vector AB bar. If AB bar is a vector parallel to your plane, then the dot product of normal to the plane and the vector AB bar should be 0 because they will be perpendicular to each other. So finally I need to get the vector AB bar. To get AB bar, I should have B bar and A bar. I mean AB bar will be written as B bar minus A bar. So B bar is already known because the coordinates of B are known to me. And finally I need A bar. The way I will get A bar is from the equation of the line. Now this is where certain students get confused, that this is not the equation of line that we have learned. We have learned the equation of line as A bar plus lambda B bar. It is exactly the same form only. Think about R bar equal to A bar plus lambda B bar. You would always write A bar as x1 I cap plus y1 j cap plus z1 k cap, and B bar as ai cap plus bj cap plus ck cap. Now expand whatever you have just got. So when you expand and simplify to get all terms in I cap, j cap and k cap, you will realize that the equation has become x1 plus a lambda the whole into I cap plus y1 plus b lambda the whole into j cap plus z1 plus c lambda the whole into k cap. And that is exactly the form in which they have given the equation. So this equation or the original one that you have learned are actually one and the same. In the original equation, if you remember, R bar was the position vector of any point on the line. So over here, my point A is a point on this line. So R bar can represent the position vector of point A also, just that the moment I write R bar as A bar, the value of mu is going to get fixed, because I had mentioned that the parameter value will be fixed for every single point and it will be different for every point on the line. So the moment I write A bar in place of R bar, the value of mu is going to get fixed, and that fixed value is what we are trying to find in this sum. So now, like I said, I just replace R bar with A bar, and whatever I have over here is the position vector of my point A. The next thing I wanted was AB bar. Like I said, AB bar will be obtained by taking B bar minus A bar. B bar is 3i, 2j, 6k. Minus A bar is going to be this vector only. So A bar will be 1 minus 3 mu into I cap, mu minus 1 j cap, and 2 plus 5 mu into k cap. Just imagine I have written it over here. So when you subtract the terms, you get 3 minus 1 plus 3 mu, that will be 2 plus 3 mu. So I get 2 plus 3 mu into I cap, plus the term I will get in j cap will be 2 minus mu plus 1, so that will be 3 minus mu, plus I will have 6 minus 2 minus 5 mu, that is 4 minus 5 mu, the whole into k cap. So this becomes my vector AB bar, and like I said, my vector AB bar is parallel to this plane, So the vector AB bar is perpendicular to the normal to this plane, and the normal to this plane is I cap minus 4j cap plus 3k cap. Since the normal and vector AB bar are perpendicular, their dot product will be 0. Take a dot product of the two vectors. So we will have 2 plus 3 mu, the whole into 1, plus we will get 3 minus mu, the whole into minus 4, plus we will have 4 minus 5 mu, the whole into 3 equal to 0. Simplify that expression and you will get the value of mu. Solve it quickly along with me. So we have 2 plus 3 mu, then we have minus 12 plus 4 mu, and then we have 12 minus 15 mu equal to 0. So that plus 12 and minus 12 get cancelled. We have 3 plus 4 7 minus 15 which is minus 8. That minus 8 goes here. So I have 8 mu equal to 2, and that is why mu will be equal to 1 by 4, and that makes option C the right answer for this question. The next question, I have taken it from 10th January 2019, the morning session. Now this question is very easy. It's too straightforward. It tells you to find first of all the equation of the plane which passes through this point and parallel to this and this line, and then they are asking you that this plane will pass through which of the given options. So all you need to do is find the equation of the plane. You know a point through which that plane passes, and the second thing you require is a normal to the plane. The question says that the plane is parallel to two lines. So if the plane is parallel to two lines, then taking a cross product of the two lines will give you a vector which is perpendicular to the plane. So just take a cross product of these two lines, and when I say cross product of two lines, I mean cross product of vectors which are parallel to the two lines. So the normal vector will be cross product of 3i minus j plus 2k and I plus 2j plus 3k. So the cross product becomes determinant of ijk, the first row being 3 minus 1 and 2, and the second row being 1, 2 and 3. Just evaluate the determinant. You have minus 7 I cap, then you have 9 minus 2 which is 7, so minus 7 j cap, and with k cap you have 6 plus 1 which is 7 k cap. That is your normal to the plane. So the equation becomes minus 7, the point is 4 minus 1 2, so x minus 4, then you have minus 7, y plus 1, then you have plus 7, z minus 2 equal to 0. You can pull out a 7 common from all the terms, or if you want, pulling out a minus 7 will also be okay. Pull out a minus 7 common from all the terms and take that minus 7 in the denominator on the right. So the denominator will be 0 upon minus 7 which is 0, and we will be left with x minus 4 plus y plus 1 minus z plus 2 equal to 0. So that gives us x plus y minus z, and then we have minus 4 plus 1 plus 2, making it minus 1 equal to 0. Just substitute all the points in this equation. So if I substitute the first point, I have minus 1 plus 1 minus 1. So minus 1 minus 2 plus 1 minus 1 is 0. So I am left with minus 2 which is not equal to 0. So the first point does not satisfy that equation. Substitute the second point, which is minus 1 and 1 in the equation over here. Minus 1 and 1 is going to give me minus 4 on the left, which is not equal to 0. So even the second option is wrong. Try substituting the third option in this equation. So when you put in the third option, you have 1 plus 1, 2. Then you have minus of minus 1, which is plus 1 again, which is 3. 3 minus 1, 2. It's not equal to 0. So option C also does not satisfy. It's the wrong answer. And try substituting the last point. So we have 1 plus 1 minus 1 minus 1, which is actually 0. So option D satisfies the plane, and that is why option D out here is the right answer. Yet another question from the same paper. The question says, if the lines x equal to ay plus b, z equal to cy plus d, and x equal to a dash z plus b dash, and y equal to c dash z plus d dash are perpendicular, then which of the given options is right? Now what they have given to us is not really the equation of a line. Check this equation. This is actually the equation of a plane. Even this is the equation of a plane. So actually what they are saying is, if this is one plane and the other is the other plane, they have a common line of intersection. So get the equation of that line of intersection. The equation of line of intersection of this plane and this plane and this plane and this plane, that line that you get is going to be perpendicular to each other. Those two lines are perpendicular. So if those two lines are perpendicular, then which of the given options will be satisfied? Now, in your theory, you have not learned how to find the equation of line of intersection of two planes. So what we will do is, we will try to get the equation of lines in some or the other, by some other technique. So if you realize these two planes, see, when they say get the equation of a line, equation of a line is of the type x minus x1 upon a equal to y minus y1 upon b equal to z minus z1 upon c. So we have to focus all our thinking on bringing the equation of a line. And when I say equation of a line, you need to get an equality between some expression of x equal to some expression of y equal to some expression of z. So can we do that with the two equations that we have over here? Let's think over it. Can we, okay, x has been given to us in terms of y and z also has been given to us in terms of y only. So what we will do is, we will try to evaluate y from both the equations. I can say x minus b upon a will be y, but that y in turn will be equal to z minus d upon c. Now when I do that, the equation looks like this. I have x minus b upon a equal to y, but that y is further equal to z minus d the whole upon c. Think of it as y upon 1, and now whatever I have is actually the equation of a line. So the equation of a line from these two equations can be obtained in this manner. Similarly, equation of your second line will be obtained by doing the same thing for your second equation. In the second equation, x has been given to me in terms of z and y also has been given to me in terms of z only. So let's try writing both of them in terms of z. I get x minus b dash upon a dash equal to z, but that z is in turn equal to y minus d dash the whole upon c dash. So finally I have this term and this term, both of them equal to z, and I will think of it as z upon 1. Finally I have my two lines, and the question says that these two lines are perpendicular to each other, and because these two lines are perpendicular to each other, I will say that a vector parallel to both the lines are also perpendicular, and which is why their dot product will be 0. A vector parallel to the first line is ai cap plus j cap plus ck cap, and a vector parallel to my second line is a dash I cap plus c dash j cap plus k cap, and taking their dot product and equating them with 0 will give me the final answer. So when I take a dot product, I have a into a dash plus I have 1 into c dash plus I have c into 1, and this should be equal to 0. So that tells me that option B out here is the right answer. Let's go ahead with the next question. I have taken it from 9th January 2019 papers from the evening session. The question says the equation of the plane which contains this line and it is perpendicular to the plane which contains the two given lines over here is which of the given options. So first of all, check the first point that they have given. Our required plane is containing this line. Now just have a look at the equation of that line. The equation of a line is written as x minus x1 upon a equal to y minus y1 upon b equal to z minus z1 upon c. Think of this equation as x minus 0 upon 2, y minus 0 upon 3 and z minus 0 upon 4. So I realize that this line passes through the point 0, 0, 0. That means origin is a point through which the line passes, but the line is already there inside the plane. So if the line passes through the origin, the plane also passes through the origin. To write the equation of a plane, I need a point through which the plane passes and a vector which is perpendicular to the plane. From the first point, it is very clear that since origin lies on this line and the line lies in the plane, origin lies inside the plane. So a fixed point through which the plane passes will be the origin. Second, what I require is a normal to the plane. So for that purpose, have a look at the second point. It says that my required plane is perpendicular to the plane which is going to contain this line and this line. So there are two lines, say for example something like this, these are two lines. There is a plane which contains the two lines and our plane is perpendicular to this plane. So our plane is this. Now we need a vector which is perpendicular to this plane. So what we will do is, we know two lines which are there in this plane. Take a cross product of these two lines. So when you take a cross product of these two lines, you get a vector which is over here. Now still this vector is parallel to the plane. It is not perpendicular to the plane. But if you realize, then in the first point, they have also given you a line which is there inside the plane. So in this plane, in our required plane, they have given a line. We just got a vector over here by taking the cross product of these two lines. So I have this vector, I have this vector. Vectors can be shifted parallel to themselves. Now when you take a cross product of these two vectors, you will get a vector over here, which is a vector perpendicular to the required plane. So we have to take a cross product two times, and that is what will give us a vector which is perpendicular to the plane. So I first take a cross product of these two given lines, and the way I will take their cross product is, I will take the cross product of vectors which are parallel to the two lines. So the vector parallel to this line is 3i 4j 2k. The one parallel to this is 4i 2j 3k, and their cross product is determinant of I, j, k, 3 4 2, 4 2 3. Evaluate the determinant, you get 12 minus 4, which is 8i. Then you have 9 minus 8, which is 1, but there will be a minus sign at the start of j cap. And finally k cap will be multiplied with 6 minus 16, which is minus 10 k cap. Now this vector's cross product is what I am going to take with the vector 2, 3, 4 or 2i 3j 4k. So I have a determinant I, j, k. The first vector 8, minus 1, minus 10, and the second vector which is 2, 3, 4. So take a cross product, you will have I multiplied by minus 4 plus 30, which is 26 I cap, minus j cap multiplied by 8 into 4, 32, 32 plus 20, which is 52. Okay, so plus 52 and there will be a minus, so minus 52 j cap, and k cap multiplied by 24 plus 2, which is plus 26 k cap. This is a vector which is perpendicular to my plane. So the equation of my plane will now be given by a into x minus x1 plus b into y minus y1 plus c into z minus z1. So the equation becomes 26. Keep in mind ABC were the DRs of the normal, which are 26 minus 52 and 26. So a 26 into x minus x1, x1, y1, z1 were 0, 0, 0 because our plane was passing through the origin. Then we have b which is minus 52 into y minus 0 plus we have c which is 26 into z minus 0, and this should be equal to 0. You can pull out a 26 common from all the terms, and that 26 can go on the right hand side. 0 upon 26 will be 0 only. So I will be left with x minus 2y plus z equal to 0. This is the equation of our required plane, and that makes option B the right answer for this question. The next question, again a question from the same very paper. The plane passing through the line of intersection of this plane and which is parallel to the y-axis, that plane will pass through one of these given points. So you need to find the equation of the plane, substitute these options in the equation of the plane, and whichever option satisfies, our plane will pass through that point, and that will be our final answer for this question. So equation of any plane that passes through the line of intersection of these two planes will be given by P1 plus lambda P2 equal to 0. So I will write P1 as x plus y plus z minus 1. I am writing that minus 1 because the right hand side should be maintained equal to 0, plus lambda times P2, which is 2x plus 3y minus z plus 4, the whole thing equal to 0. I just need to get everything in terms of x, y and z. So the coefficient of x becomes 1 plus 2 lambda into x, plus I get 1 plus 3 lambda into y, plus I get 1 minus lambda into z, plus we will have minus 1 plus 4 lambda equal to 0. Now this is the equation of our required plane, and our required plane, they have said is parallel to the y-axis. This is y-axis and this is our plane. If the plane is parallel to y-axis, normal to the plane is perpendicular to y-axis. The normal to the plane has the drs this, 1 plus 2 lambda I cap, 1 plus 3 lambda j cap and 1 minus lambda k cap. So that is the normal to my plane, and a vector parallel to y-axis will be j cap. So the dot product of j cap and the normal vector over here should be equal to 0. The dot product will be this multiplied by 0, this multiplied by 1 and this multiplied by 0. If you remember, the dot product was taken by multiplying coefficients of I cap, j cap and k cap. So my first vector is 1 plus 2 lambda I cap. This is how I am writing my normal. And like I said, the dot product will be taken with a vector parallel to y-axis, which is j cap. And I can write j cap as 0 I cap plus 1 j cap plus 0 k cap. So now take a dot product. You will have this term multiplied with 0, second term with 1 and the third term multiplied with 0. So finally, okay, the dot product also has to be 0 because the vectors were perpendicular. So I have 1 plus 3 lambda into 1 equal to 0. That gives me lambda as minus 1 upon 3. The moment I put lambda as minus 1 upon 3 in the equation of my plane, I get the equation of the required plane. So put lambda as minus 1 upon 3 here. You have 1 minus 2 upon 3, which is 1 upon 3. So the first term becomes x upon 3. This will be 0. So I will not have any term in y. And 1 minus of minus 1 upon 3 makes it 4 upon 3. So I have plus 4z upon 3. Over here I will have minus 1 minus 4 upon 3. So minus 1 minus 4 upon 3 makes it minus 7 upon 3 equal to 0. I can multiply throughout by 3. So the equation becomes x plus 4z minus 7 equal to 0. Now whichever point satisfies this equation is our answer. Let's check for the first point. Minus 3, 0 and minus 1. So I have minus 3, minus 4, minus 7. Minus 3, minus 4, minus 7 is not equal to 0. So option A is wrong. Substitute the second option. I have 3, minus 4, that is minus 1, minus 7. 3 minus 4 is minus 1, minus 7 is minus 8, not equal to 0. So option B is also wrong. Check for option C. 3 plus 4, that is 7, minus 7 equal to 0. Yes, option C might be the right answer. Check for the last one. And then I have minus 3 plus 4, which is 1. 1 minus 7 is minus 6, not equal to 0. And that is why option C for this question is the right answer. Yet another straightforward question. Have a look at it. The plane which bisects the line segment joining this point and this point at right angles passes through which of the given points? So what they are saying is there are 2 points given to you. Let's take the first point as A and the second point as B. And there is a plane which is bisecting the line joining these 2 points at right angles. So the plane is going to go like this. It is bisecting the line and that too at right angles. And now they are asking you that this plane passes through which of the given points. So all you need is the equation of this plane, and after you get the equation of this plane, you just need to substitute the points and check which point satisfies the equation. To get the equation of your plane, you need 2 things: a point through which the plane passes and a vector perpendicular to the plane. It's very clear that the plane is passing through the midpoint of A and B. The midpoint of A and B can be obtained by the midpoint formula. So the midpoint of A and B will be 3 plus minus 3, which is 0, divided by 2, that will be 0. Then we have 7 plus minus 3, that is 4, divided by 2 will be 2. And then we have 6 plus 4, 10, divided by 2, that is 5. So our plane passes through this point. And we need a vector perpendicular to the line, which is the vector AB bar itself. I can write the vector AB bar as B bar minus A bar. So when I say AB bar, which is B bar minus A bar, that will be 3 minus minus 3, so 6 I cap, plus 7 minus minus 3, so 10 j cap, and 6 minus 4, that is 2 k cap. I have the normal vector, so the values of ABC are 6, 10 and 2, and the values of x1, y1, z1, that is the coordinates of a fixed point through which the plane passes, are 0, 2, 5. So the equation of our plane becomes 6 x minus 0 plus 10 y minus 2 plus 2 z minus 5 equal to 0. A x minus x1, b y minus y1, c z minus z1. The values of ABC are 6, 10, 2, x1, y1, z1 is 0, 2, 5. So let's go ahead with simplifying this. We can pull out a 2 common and take it on the right hand side. So we will be left with 3x. Over here we will be left with 5y. And over here we will be left with plus z. And the numbers will be nothing from here. From here, remember we had taken a 2 common. So here we are left with 5. 5 into minus 2 will be minus 10. Minus 10 and minus 5 make it minus 15. Start putting in the options. So when you put in the first option, you have 12 minus 5. 12 minus 5 is 7. 7 plus 7, 14. 14 minus 15 minus 1 not equal to 0. Option A is wrong. Go for option 2. So 3 into 4, 12. 12 plus 5, 12 plus 5, 17. 17 minus 2, that is 15, and 15 minus 15, 0. So option B becomes the right answer. Like I have said, to be on the safer side, check for option C and D as well. I am leaving that work up to you. When you substitute option C and D in the equation of this plane, you will realize that these are not going to satisfy the equation, and that is why C and D will also be wrong. So finally option B is the right answer for this question.